So we're going to recap the 3 things that you need to be able to do with fractions easily, quickly and efficiently in order to then add, subtract, multiply and divide. So the first thing we need to look at is equivalence. Now equivalence is, the word comes from Latin, surprise, surprise, equi meaning equal, valence or valent, equivalent, coming from strength. It means equal strength. So what that really means is that if I give Sheldon a $1 coin and I give Jordell 2 50-cent coins and I give Jasmine 5 20-cent coins and I give Matilda 10 10-cent coins, they've all got the same amount of money. You can't get them. You can in America, they're called quarters. But they have an equal value. They're different though, because you've got 1 coin, 2 coins, 5 coins and 10 coins. So they are actually different, but they do have an equal value, which is why they're called equivalent. Okay? So when we look for equivalent fractions, what we need to look for is we look at the numerator and the denominator. I hope you're writing all this down and thinking about it. The numerator and the denominator, and we have to make sure that in the new fraction, the numerator and the denominator are in the same proportion. Okay? So let's start with something like 2/5. And we're going to write some equivalent fractions to 2/5. So what will normally happen is that you will be given either the numerator or the denominator of the new fraction. So let's say here we're going to be given a new denominator of 40. Okay? So I'm just going to write it here, but you can write it underneath. So you've got 2/5 is equivalent to something over 40. What has to happen is that the relationship between the denominators has to carry out up in the numerators as well. So the relationship between the denominators, i.e. what has happened to the 5 to make it 40, we have to do the same thing to the 2 to make the new numerator. So what has happened to the 5 to make it 40? Multiply by 8, that's right. So, remember, when we treat the numerators and the denominators, we have to treat them exactly the same. So we also times the denominator by 8, which gives us 16. So our equivalent fraction is 16 over 40. Okay? Right then, let's try with a new numerator. So the process is exactly the same. It's just that you look at the relationship between the numerators and then translate that to the denominators. So 2 over 5 is equivalent to 8 over what? 20. Well done. Okay. New denominator of 35. Okay.
Maybe 14.
14. That's right. 20. Numerator of 20. Oren?
8. Oh, no, sorry.
So new denominator we're looking for.
50.
50. Well done. Okay. Right, can someone just give me then an entire equivalent fraction? I won't give you the numerator or the denominator anymore. You just tell me a new one. Jordell?
4 over 10.
4 over 10. Good. Is your hand up, Louis?
No, sorry.
Okay. Tyler?
32 over 80.
32 over 80. What have you multiplied that both by? 16?
Yeah.
Yeah, well done. One more then.
8 over 20.
We've got that one already, yeah. But it's right.
10 over 25.
10 over 25. Well done. And then just one more.
100 over, oh no, 40 over 100.
40 over 100. Well done. You've linked it to the decimals, haven't you? So equivalence We're all pretty good with that. Are we all okay? So it's pretty easy. What you've just got to remember to do is look at either the numerators that you've got in common or the denominators that you've got in common. Check the relationship and apply it to the missing one. Okay? Right then, simplifying. Now this can be called various things. When I was at school, we called it cancelling. You also might see it called lowest terms. Anyone else think of another way that it's spoken about? It's just one more, simplest form. So what we always do, if you are answering a fractions question and you arrive at an answer that isn't in simplest form or isn't in lowest terms, the expectation is that you will always simplify it, okay? Unless it's an equivalent one, because obviously you're not going to give that as an equivalent fraction and then simplify it, because it's just going to go back to that again. But when you're adding, subtracting, multiplying, dividing, you will always give in lowest terms. Okay, so it's very important not to forget to do that, because there is always a mark allocated for doing that. So if we have something like 21 over 49, what do we need to look for?
The highest common.
Well done. We're looking for the highest common factor, so the HCF. Now, remember, it doesn't matter if you don't find the highest common factor straight away. You can always simplify again, but it's easier if you can find the highest common factor straight off. So what is the highest common factor of 21 and 49?
7.
7. So the highest common factor is 7. So that means then that we divide both the numerator and the denominator by 7. So 21 divided by 7 is 3, 49 divided by 7 is 7. So 21 over 49 in lowest terms is 3/7. Okay? Let's just have a look at another one. 13 over 39. Now this one, you might think, won't be any common factors because 13 is a prime number, isn't it? But then you need to look at the denominator. 13 is the highest common factor. So how many 13s are there in 13?
1.
1. How many 13s are there in 39?
3.
3. So your simplified form is 1/3. Okay? All with me? Now the only difficulty is when you're given really big numbers. So like something, big numbers that you don't necessarily know the highest common factor for. If that really happens, what could you do? If you don't have your calculator, because you do you know how to do it on your calculator?
Yeah, click the A-B button.
Yes, I'll teach you how to do it later.
Like just divide by like a 2 or a 5.
Yes, very good. Look at the prime factors. So if, for instance, you've got two big numbers, think of what your prime factors are and divide by those until you get to the same number. So we've got equivalence, simplifying, and then our last thing that you need to know how to do is conversion. And this is when you are given either a mixed numeral and you need to convert it into an improper fraction, or you're given an improper fraction and you need to convert it to a mixed numeral. Okay? The expectation again is if you end a question when you've added or subtracted and it's an improper fraction, the expectation is that you convert it to a mixed number. Okay? So let's have a look at 43 over 6. So 43 over 6 is an improper fraction because the numerator is bigger than the denominator. It's top heavy.
7.
So, how do we do it? What do you need to think about? Come Montana?
Would you turn it into a mix?
You would turn it into a mixed numeral, but how would you do that?
Would you see how many times?
Very good, that's right. You see how many times 6 divides into 43 and what the remainder is going to be. Now, obviously, you're going to have in your answer an integer, and then you're going to have a common or a vulgar fraction left over. The denominator won't change. In these conversion ones, the denominator always stays the same. So you know it's going to be a whole number plus some sixths. So 6's into 43 goes 7, remainder 1. So there's your answer. 7 and 1/6. Now obviously you will have a bit more practice doing these, but I'm only going to give one example of each one at the moment. So if we've got 9 and 2/9, and we need to change that into an improper fraction, what can you tell me again about the denominator?
You would, in this case, you would times the denominator.
What's the denominator going to be?
9.
It's going to stay the same, isn't it? So you know that automatically. With these ones, the denominator stays the same. So then what do we do?
You would times the denominator and the integer
Yeah.
to give you the amount of nines, and then you would add how
Very
many
good.
nines there already
So
is.
in 9 whole ones, there will be 9 times 9 ninths, won't there? Does that make sense to you? Because in each whole one, there's going to be 9 ninths. So if you've got 9 whole ones, it's going to be 9 lots of ninths. So that's 81. And then you need to add these 2 random spare ones, 83. So 83 over 9. Okay.